Hello everyone. So, unfortunately the audio for the first approximately 20 minutes of the lecture didn't work. This is through my fault. I forgot to put the microphone on, so I apologise for that. So there has been some delay in getting this lecture up. But what I thought I'd do, I just thought I'd talk to myself in my office over the first 20 minutes or so of the lecture, so that you won't be missing out. Sonia's lecture is up right now, so that covers pretty much the same information, although she may stress different things being important than what I do. So the things that were important back then may not necessarily be as important now, and vice versa. So it's best that you use my lectures. So yeah, so please, I apologise, very sorry, but you should have all the same information. So this lecture is going to be on the neurochemistry of drug reward, and what I'm going to do is I'll hopefully, if my editing skills are up to scratch, I'll be able to edit this together with the actual recording from the lecture. So this lecture is about the neurochemistry of drug reward. My name's Graham Nibb, in case you don't know already, and that's my email address here. I'm in office 230, and they're my office hours there. So if you do have any questions about the content of these lectures, then feel free to email me or attend my office hours. I'm also pretty much available anytime, so if you are about and you have an urgent question, feel free to knock them in. I'll be happy to see you. And the reading for these lectures and the previous one is Carlson chapter 4 and Pennell chapter 15. So there's an online test, so that'll be up online from the 17th of April and will be up until the 24th of April from 9 AM both days. And this online test covers lectures 8 and lectures 9. So the aim of this lecture then is to discuss how psychoactive drugs are administered, how this may impact the drug's effects. We're going to describe the reward system, the mechanisms by which drugs act on this system. I'm going to describe a number of psychoactive drugs which act on this reward system, and outline a number of different neurotransmitters which are also affected by psychoactive drugs, and also introduce the concepts of withdrawal and tolerance as well. So in parallel to this, your learning objectives that you should obtain after watching this lecture and the associated revision is, by the end of this lecture, you should be able to describe how methods of administration affect drugs' effects, understand what the reward system is and how this may lead to drug use, describe a number of different drugs and how they exert an effect on the reward system, understand how other neurotransmitters produce drug effects. So in particular we're going to talk about serotonin and how that may lead to different effects, particularly hallucinations, and you should be able to describe what is meant by withdrawal and tolerance as well. So what I did in the lecture and what I'll do now is sort of talk a little bit in detail about different drugs of abuse, how they're classified and how they are regulated in both the US and the UK as well. Because I do think it's important for you to understand this, because we are talking about mostly illicit and illegal drugs, so it is good background knowledge to have. So there are a number of different drugs of abuse. So we have nicotine, alcohol, cannabis, opioids, stimulants like cocaine, amphetamine, methamphetamine as well. There's hallucinogens, so drugs which have a hallucinogenic effect, such as LSD, mescaline, psilocybin. Club drugs like MDMA, which people like to take when they go for a drink and dance. PCP, which we'll talk about later on. There's inhalants, and there's also prescription medications as well, such as opioid pain relievers, different stimulants, depressants, etc. So the way in which these drugs are classified in the US differs quite a lot from the way they're classified in the UK. So in the US, they have what are called schedules of drugs. So, and they're sort of sorted by how likely they are to be abused, their effects, and whether or not they have any accepted medical uses. So for example, Schedule 1 drugs. So these are drugs which tend to have a high potential for abuse and currently have no accepted medical use. And there's concerns about the safety of the drug. So this includes things like heroin, cocaine, crack cocaine, amphetamines, etc. And basically all of the illicit drugs. Alternatively, Schedule 2 drugs concern drugs which do have a high potential of abuse still, but they don't currently have any they do currently have an accepted medical use. So an example of this is morphine. So morphine has a very high potential for abuse. People do become addicted to it, but it does have some accepted medical uses. So to treat pain, and it can be prescribed and given in hospitals. And yeah, so abuse of these drugs may lead to severe psychological or physical dependence as well, but they do have medical uses. And there's Schedule 3 drugs, so an example of this in the US is ketamine. So this is where they have a high potential of abuse, but it's less than the drugs that it's classified as Schedule 1 or 2. And these drugs also have an accepted medical use. And the use of these drugs may lead to moderate or low physical dependence or high psychological dependence. So things like ketamine, although they are used illicitly, can also be used medically as well. So particularly for ketamine, they're often used on pets and horses, which is why it's ketamine sometimes called horse tranquilizer. Ketamine was originally developed as an anaesthetic to be used on adults, but they don't do it anymore because they realise it has some quite profound effects. But it is still used on animals and children as well, funnily enough. So in the UK, it's slightly different. So we have different classes of drugs. So we have like Class A drugs, Class B drugs, Class C drugs. And the way in which this is organised is in terms of the punishment you'd receive for possessing these drugs. So Class A drugs, things like ecstasy, LSD, heroin, cocaine, crack cocaine, mushrooms, methadone, methamphetamine, and also interestingly any Class B drug which is also prepared for injection. Because as we're going to talk about shortly in the actual lecture, the way in which you take a drug can have a profound effect on the drug's addictive potential and also the effect the drug has. So any Class B drug, so for example amphetamine, which is prepared for an injection, is automatically becomes a Class A drug even though it's the same substance. There's Class B drugs, so amphetamines, cannabis, codeine, funnily enough, Ritalin and fulcodeine. So the one I was always quite surprised to learn about was codeine. So this is a Class B drug. It can be prescribed by doctors and it can be used medically, but if you have possession of this drug without a prescription, then it is a Class B drug and you could be given up to 5 years in prison. As well as that, if you are dealing codeine, so that even means giving it to a friend who's not been prescribed it, then that is technically dealing, supplying drugs, and so you could be given up to 14 years in prison. So try not to worry too much, but next time you prescribe codeine, maybe just keep it to yourself. And there's Class C drugs as well. There's these things like tranquilizers, some other painkillers, GHB, and ketamine as well. And I added this last minute. This isn't going to be assessed in any way, but I think I can't really talk about classifications of drugs without now talking about the Psychoactive Substances Act from 2016. So basically, a few years ago there was a influx of new synthesized drugs. So a lot of people were making new drugs and selling them as with lots of different uses. So they were being advertised as plant fertilizers, car lubricants, things like that. And these started to be sold in sort of head shops, so shops which would sell these drugs, but would advertise them as being for different uses. But everybody knew that really they were just being sold to be used as psychoactive drugs. So in response to this, the government introduced the Psychoactive Substances Act. So this made it an offence to supply, produce or offer any psychoactive substance if it's likely to be used for its psychoactive effect. Quite crucially, regardless of the potential for harm. So even if there was a drug created which was perfectly safe to use but had a profound psychoactive effect, but it wouldn't cause harm to the user in any way, then this would still be banned underneath the Psychoactive Substances Act. There are some exemptions, so nicotine was exempted, alcohol, caffeine, some medicinal products as well. And originally, poppers would also amyl nitrate, otherwise known as poppers, were also going to be banned, but they were later exempted. And the main reason for this is because poppers are often used quite extensively in the LGBT community, and the worry was that they would instead of using poppers, would use more harmful drugs. So therefore, poppers were exempted. And the aim of this act was to shut down these head shops, or these shops which sold these drugs. So this act was controversial before it was even enacted. So, but people were worried about what kind of things would be covered, what kind of things wouldn't. And one of the arguments that was always sort of brought up was the case of nutmeg. So nutmeg is quite nice, but if you take it in high doses, it can have hallucinogenic effects. And so people were saying it's quite nonsensical to ban all of these substances and not to ban nutmeg, so is that going to be banned, etc. It wasn't, but that was the worry at first. And some people have criticised this act because they're worried that they may have pushed the sale of these so-called legal highs underground. So instead of some hippie in a head shop being making some money off it, instead they may have just basically handed over a lot of drugs to criminal organisations who could sell these drugs to make a profit. So these organisations would often use crime, violence for their gain. And this started with the introduction of MCAT. So MCAT was the first legal high to receive a lot of prominence in the tabloids, and it was in the tabloids with a lot of stories about how many deaths MCAT was caused and things like that. The problem was, so MCAT got banned pretty quickly and wasn't subject to Psychoactive Substances Act. But the problem is, some people have criticised this move because what seems to have happened was when MCAT was introduced, there seemed to be a decrease in the amount of admissions to emergency services, so into A&E, due to cocaine use. So people may have been using MCAT instead of cocaine, and that could have been good. So having MCAT could be a good way of reducing the amount of deaths, the amount of injuries caused by cocaine, because it's not as harmful as cocaine, although it is still harmful. So if MCAT was kept legal, maybe we would have actually seen a reduction in the amount of harm through cocaine use. So that's quite controversial. So for these so-called legal highs, it's not an offence to possess it, and you can't be indicted by the Crown Court, but there are some punishments for possession of it in a custodial institution, possession with intent to supply, production, supply, failure to comply with prohibition or premises notices as well. So actually, when this came out, people thought it might actually be a more progressive way at looking at punishing drug use, because it's not an offence to possess. And some people would argue, myself included, but other opinions are available and you may have your own opinion on this, that I don't think that people should necessarily be punished for possessing drugs, at least. So this does seem to actually be a more forward way of thinking about how we control drugs. Okay, so what we talked about then is we talked about the brain reward system and watched a video which summarises some of the information which we covered in the last lecture. So I'm not going to play this video now, but if you want to watch it, it's on the slides that are uploaded. So just go on it yourself, have a look, and it basically summarises information to do with the reward system, which we have talked about previously. So reward circuits, as we talked about last week, have evolved to ensure survival in primitive conditions. So whenever we do anything which is beneficial to our survival, we get a reward. So dopamine is released, and this makes us feel really good, and it makes us want to repeat the behaviour. So this is important for survival because we get this release when we eat food, when we drink, when we have sex, when we protect our children, and it allows the species to carry on, basically. And the bigger the more advantageous the behaviour is, the bigger reward you'll get. So for example, if you were to consume a slice of lettuce, then you would get a mild release of dopamine, so it's quite rewarding but not really. But if you were to consume some ice cream, then which is high in fat, high in sugar, and most importantly high in calories, then a bigger amount of dopamine is released, and leads to a greater amount of reward, so you're more likely to repeat that behaviour. So in the past this was quite important, because if you're going out hunting all day, using a lot of calories, it's important that you're consuming high calorie foods. But nowadays this becomes a problem when food is so easily available, and then that could lead, has been suggested to lead to things like the obesity crisis, which we're going through right now. So reward circuits have evolved in order to ensure our survival, and psychoactive drugs also act on this reward system as well. So people refer to them as hijacking the reward system. So we take a drug, it releases dopamine, which feels rewarding to us. And as we talked about last week, there's a number of theories around why this may be. So for example, it could have been that in the past consuming drugs was actually beneficial to us, but no one really knows. So that's how our reward circuits have evolved. And we can see there's quite a lot of evidence for it. So in this example, so this is the brain of someone who is exposed to a neutral cue, so not really to do with anything. And this is the brain, so it's a PET scan, of someone who is eating highly palatable food. So by palatable I mean really good tasting, probably high in sugar, probably high in fat, almost definitely high in calories. And this area here and here is the nucleus accumbens, and the redder it is, the more activity is going on. So as we can see, there's much more activity going on in the brain of someone eating highly palatable foods than there is someone being exposed to a neutral stimuli. So highly palatable foods are releasing a lot of dopamine in the nucleus accumbens. This example also shows you in animals. So in animals, we can see a lot of different stimuli release dopamine. So on the y-axis, this is the release of dopamine, and these different letters tell us the activity which the rat, which is being tested in this case, is undergoing. So we can see here dopamine starts pretty low. It then increases slightly when the rat is on the wheel. So this is because exercise can release some dopamine, can be rewarding, so I've heard, at least not to me, and some dopamine is being released. The rat starts to run, and again some dopamine is released, and then as you can see that goes on. What happens then over here, so with C, is the rat is placed into what's called the mating chamber, which I think sounds quite sinister. So this is a chamber where the rat has previously mated with a female rat, and so it kind of knows what's going to happen, and you can see the dopamine increases. Some fresh bedding is put into the chamber, and dopamine decreases a little bit. But then what happens is some soiled bedding is put in, and as you can see the dopamine increases. So this bedding has been soiled by a female rat. So the male rat can smell the female, and again he's expecting that a female will be put into the mating chamber at any point, so he gets a bit excited. So dopamine becomes released. And then this part here is when they're exposed to a female. So the female is behind the screen, so they can't get to the female, but they can see her. And again, dopamine release increases. And then G is where the screen is removed, and as you can see, there's a high amount of dopamine release. And so yeah, so the screen's been removed. We can all guess what the rat's doing. Yeah, and then once they've finished, you can see that dopamine starts to decrease again. So this shows that a lot of behaviours which are crucial to our survival also release dopamine. So sex, exercise as well releases dopamine, the expectation after sex, and in this case in humans, consuming highly palatable foods. So that is everything that was not recorded, and so hopefully if I'm successful I'll be able to edit together this with the audio from the lecture. Thank you very much, and I apologise again.